till Monday evening, or is it Monday midnight? I don't remember. Or is it Monday before class? I think it may be Monday midnight to complete the NetAcad modules 8 through 10. Open book, open notes. All right, so let's do some review.
It's not showing up in my Schoology.
You go to netacad.com.
I know, you should, in the past, run a Schoology reminder.
Yeah, Schoology.
It was like last Friday.
Right, okay, I'll update that. That was the thing. I went there and said, hey, man, we missed that. I said, well, I'll give you some slack. We've been troubleshooting, having physical access to the equipment, getting actual physical equipment working. You have to learn a lot. And working with physical cables, for some, it's like a whole different world. You sit and stare at the cables and you wonder, wait a minute, this isn't something on the screen that I can grab with my mouse. I physically have to touch it. And for some people, it's a whole change in the world. And some, it's like, oh yeah, done this on the screen, I can do it physical. Others, you'd see it's a whole new thing. That's why having physical equipment, even old stuff, will get you ready for the real world, which is real equipment out there. You don't manipulate virtual routers when you're working as a networking support.
Let's put a bit faster.
Frank like manage cables.
Yeah. Here, let's drag the cable to this other port. Now it works.
Oh, it is going a bit faster. Let's see.
The backup of the iOS to the TFTP.
Wait, make this screen again.
All right, so let's go through a few questions here. We'll take turns at the questions. Let's see if this is all going to work for us. I put this in. Basically, there's a test bank on netacad.com that lets me see all the questions that are there. When you take the quiz, you probably won't see all the questions, but you should. From what we covered, these questions should be in there. So we're covering more. We're doing a little bit teaching to the test, but there is so much here that sometimes that's what you're stuck with. I've heard a lot of certification courses, they're not giving you a lot of experience. They're getting you ready for the quiz. You take the quiz. You still may be very poor in networking practice, but that's what certifications often mean. You learn how to take the test. So we're doing a little of that, but then we're going to go back and physically connect real equipment where the challenge comes. And a good comment was, I never showed you actually how to erase your configuration. That would have been a good place to start. Lesson learned, and you'll now know how to erase configurations, figuring out on your own. So let's take a look at a few questions regarding ARP. A computer can access devices on the same network, but cannot access devices on other networks. What is the probable cause of this problem? Not connected network? Well, that wouldn't be true because I can access local devices. Invalid default gateway address has been proposed. Incorrect subnet mask?
You still won't be able to connect to one network.
Invalid IP address. Those two in the middle seems to me would cause problems on my same network. Yeah, so this is the only one that has to do with these could be working, but I can't get to other networks. That's the most likely. Now, another thing we've seen in our practice is we have the default router set as our gateway address, but the routers themselves aren't sharing the router information protocol. The RIP is not working between the routers, so the router doesn't know where to send it. And, of course, there's other even tougher things to troubleshoot if the routers are sort of talking. But in general, if I don't have a default gateway address, I can't get outside my local network. This is a great way to limit PCs to not, to isolate them to a network. Just leave the default gateway blank. It'll say, well, you don't have internet, but you do have the ability to share files with other PCs. So it's a safer network because you can't get to the internet, and therefore you can sandbox and have malware tests and pen testing and not accidentally do pen testing outside of your network, which would be a bad thing if you're on the school network. So yes, computer has an invalid default gateway would be the answer for that. Let's see the next one here. Which statement describes a feature of the IP protocol. Which is true, which is false. IP relies on layer 2 for transmission error control. Layer 2, remember layer 2 is our MAC address. Think of it, when you think of layer 2, think MAC addressing. Our MAC address is used during the IP packet encapsulation. IP packet. IP relies on upper layer services to handle situations of missing or out of order packets. What do you think? Anything jump out at you? I'm going to go to Medicat because they have notes on each question as well for advice.
I think it's the first one. IP encapsulation.
What do you think, Jonah?
I would agree with like
Let's see what you got here.
over there. Drum roll. Oh. Nice.
That led me astray.
I know, right?
That was such a
Out of order.
You don't change encapsulation based
Okay.
on your media.
Oh, that's right.
Layer 2 protocols does not do transmission error control. Is there such thing as error control? There's error detection and retransmission. And MAC addresses are used in the IP packet. No, IP packet puts in the IP address. I'm bringing up the test bank just so I don't miss any comments. They have comments in the test banks that I can see. So let's see. Network communication exam. I'm going to go to the assessment viewer, which is essentially I can view the quiz banks for the assessment viewer. That's how I built this presentation. And oh man, firing that up. Okay, next question. NAT and IPv6. Why do we not need NAT in IPv6? Is it because IPv6 has integrated security? You don't need to hide the internal IP address? Is it because any host can get a public IPv6 network? Because there's so many networks available? We don't have any NAT problems because the IPv6 header improves packet handling? Or end-to-end connectivity caused by NAT are solved?
Second one. Any host use
The IPv6 has so many addresses that each one's its own.
I believe you are correct. Let us check. Yes. Okay, there are so many addresses available that you don't need NAT. I still kind of like NAT though. I like hiding behind a router. So
It is really weird with IPv6 that like you have like one public address. Like everyone has a single public address per device.
Yeah.
That's like it.
Those are like, well, I think you have multiple in some cases. Just because you can.
Yeah, it's just but it's really weird. Like, does that mean when you try to like run a server off of an IPv6 address, it just by default is like doesn't need like routing or anything?
Yeah.
It just goes straight to it. Weird.
it's kind of interesting to me that it was seemed like 5 years ago, a big push, IPv6, or even 10 years ago, and it hasn't really been adopted that quickly. We still, because I think part of the problem is, part of the way through you have to support both, and supporting both is a big load on firewalls.
Well, that and also IPv6 is so much more complicated to use and implement.
And if it's still working in IPv4, what's the motivation to spend all this time to do something that's gonna be better
If you
eventually?
need it,
IPv6 probably won't be widely adopted until IPv4 is
It's just broken.
not working.
Yeah.
but the issue is like most people don't need IPv6. Like IPv4 has what hundreds of devices.
Yeah. And you can see right now, you got a little Minecraft server. You got an IPv4 address. Now it's IPv6. How do I reconfigure all that? And you think it's going to work right away? I'm thinking there's going to be all sorts of problems getting those even that little application And just imagine that for all the servers out there, oh, we drop IPv4, what breaks? So I'm not going to drop IPv4 until there is a major break. I think that's, maybe government's going to make a decree, or the internet world is going to say, we are turning off IPv4 in 2025. And if you're not ready, it's going to break. Maybe that'll bring fear.
Well, they're about to do that with USB or with Lightning.
Yeah.
Did you hear about that?
No.
Europe is now like basically creating a law that every device has to use USB Type-C to charge, except for like I think laptops are exempt and like some other smart devices. But like everything's supposed to be using Type-C now, like only because they're trying to eliminate the waste of having all these different connectors constantly phasing in and out and out. And Type-C has become so standard across most devices. Just like Apple refuses to put it on the iPhone. It just makes no sense to use Type-C. They have Type-C on the laptops, iPads, every other device.
I'm always afraid decrees to me mean someone up there that doesn't really know everything is making a decree. Maybe it'll be good, but
yeah,
I don't like decrees. I like my freedom.
I do too. I don't really like forcing companies to use a single cable, but like I know that what they're really trying to do is get Apple on board to use the same connectors everyone else on phones.
Yeah. All right. Which parameter does the router use to choose the path to the right destination? Multiple routes available. Now, so far in your setups, we haven't done the 3 routers with the possible route through different routers. What's the main parameter used? Well, the parameter to choose the path. Lower metric, lower gateway IP address, higher metric, higher gateway IP address. Well, the gateway IP address has nothing to do with it, whether it's a lower or higher, but you might think, okay, I just go through the list of my IPs. So it's either the lower or higher metric. What do you think? Is a higher metric good or a low metric good? Metric is typically a cost metric. So think of that. The metric is a cost. So we want the lower cost.
Lower metric. Metric is like a speed.
Yeah, a metric is just a measurement. And you're right, yeah. Sometimes speed, if the metric is measuring speed, you want the higher. But the metric for routers is associated with the cost. And some is, the cost is the distance. Some, like the shortest path, or some the cost or the metric is a very complex algorithm combining current load and distance. But lower is always better when we talk about router metrics.
Latency, number of hops.
Yeah, a lot of things like that. And with the fancier protocols, it becomes a more complex algorithm. And that's why eventually I'd like to use for you to know more than router RIP for configuring. My next step is to have you learn to configure OSPF. But we'll get everyone get router ripping working yet, and I don't think we're at that point yet. Just doing a quick check on my meeting here, if anyone else has showed up. No, not there yet.
What was the upload link again for the iOS files?
Down at the bottom.
The capstone?
Or is it in assignments? Look in assignments.
Oh, you're in the wrong course.
Oh, that is something else. That would be difficult.
No, it's at the bottom of this course. Yeah. Okay, 2 services provided by the OSI network layer. Network layers. Remember the acronym I remember is please do not throw sausage pizza away. P, physical, data, network, transport, session, presentation, application. What 2 services provided by the OSI network layer? That's the third from the bottom. You get to choose 2 of these. Well, please do not throw N and TR next to each other. Network is the next one below the transport layer. So I believe you are encapsulating transport layer packets. We're not placing frames on the media because we're not at the physical layer. Physical layer also does collision detection, so it's not the bottom two. Routing packets toward the destination.
I think so. Performing air correction doesn't happen until later, right? It doesn't happen until encapsulation.
You are correct. That's the MAC address. Think of it as the MAC address layer and the IP address layer, right? MAC and IP are at data and network. Okay. Why do we configure a default gateway address? On a switch. Why do we have a default gateway on a switch?
So the switch.
The router is doing the sending data to remote networks. The router is doing next hop addresses.
Well, that's so that you can assign the switch its own address, and so you can connect to it and configure
Yeah.
it remotely.
Yeah. From the local network, it wouldn't be. It would be. I believe from the local network, it'd still be accessible. But if you want to access it from the network that has routers in there, then you need the default gateway. So think of it. If I need to get to something from anywhere, or that thing needs to get somewhere besides its local network, you need your default gateway. I think it's a little bit of a tricky question because I guess I'd have to see. I don't think on the local network you could still telnet into it, but you can't telnet from another network. I'd have to prove that to be sure. All right. For Jonah, what is the basic characteristic of the IP protocol? Basic, which is true? Is it connectionless? Is it media dependent? Does it have user data segmentation? Is it reliable end-to-end delivery? Some are meaningless. One
The
is
last two seem like they actually have some meaning. Is it?
it's kind of a tricky question.
It does provide reliable end-to-end delivery.
Connectionless.
Really?
The IP protocol is connectionless. You don't establish sockets or anything. It's, hey, I'll send packets to the destination. I think that's what they're meaning. Let me look at the details of their explanation of this.
Yeah, that makes that's a weird one.
Yeah, let's see here. It looks over
I
there.
would not against that.
Here's what they explain in the question discussion. Internet protocol is a network layer that does not require initial exchange of control information to establish an end-to-end connection before packets are forwarded. That's their explanation. That IP packets network layer doesn't need a connection. It just says, okay, where you need to go, the router will send it there. And it does not provide reliable end-to-end. That's up to the application or layers above to check for resend if the checksum didn't match at the other end. IP does not do that. The transport layer does data segmentation. So a little bit of detail about the IP protocol. That layer, the IP layer, does not do any segmentation. That's one layer above. So a little details of the layer. All right. For Lloyd, which is used to prevent a packet from traversing a network endlessly.
Oh, that's time to live.
Very good. That's right. The time to live is decreased every hop, and I think it starts at 16. Very good. Jonah, what is the one advantage that IPv6 simplified header offers over IPv4? Is it a smaller header? Is it a no checksums? Smaller destination IP? Definitely not.
No.
Efficient packet handling.
I feel like it's a smaller header or efficient packet handling. Or efficient is a smaller header.
It is not a smaller header.
Is it a bigger header?
It's a bigger header. It is more efficient in packet handling. The IPv6 header offers, and they mentioned several, better routing efficiency, no requirement for processing checksums, no requirement for processing checksums. I did not realize. I thought checksums were still in there. More efficient header mechanisms. It doesn't say it's smaller though. And there is a flow label field for per flow processing. So lots of interesting things in IPv6. Again, I'd say if you want to have an advantage over other people in the networking field, be up on your IPv6 because it's going to be coming around, and it is confusing to the old timers. If you're up on it, they'll say, yeah, we want to hire these new guys. They know better about IPv6 than we do. Let them hire them to handle that. And as that becomes more important, your job will become more important. So it takes a little work because IPv6 isn't, in a lot of the documentation, everyone knows IPv4. What header field identifies the upper layer protocol carried in the packet? It is the protocol.
Okay.
Trick question. It's
I
the
was
protocol.
like,
The version identifies the IP version, IPv4 or 6. So that version is going to be 4 or 6. Differential services, that's for like voice over IP. What's the priority should I give to this packet? And I don't think, have they talked about voice over IP yet in the labs? Not
really.
That's a whole nother thing. Again, if you want to get into network, if you know voice over IP, that is huge with many companies. Knowing how to prioritize and what's involved in voice over IP. Quality of service is huge. And once everyone has their phone on the network, if the network goes down even for a second, everyone's going to hear that glitch in their conversation. You're going to get a lot more attention if voice over IP goes down and everyone's using voice over IP phones. I have not touched my Emmaus voice over IP phone for several years because I just set, as soon as I got my IP phone, I set the forwarding to my smartphone because I'm hardly in my office and it's worthless to go check messages. I just forward it to my phone and let the messages be left there. To me, it's much more efficient.
I feel like in most cases that would just make more sense.
Even when they were putting phones in student dorms, I thought, about 90%, 98% of our students have smartphones. Why do they even need a phone in their room?
well, now they switched over to Ethernet, so.
Is it?
Or no, I think they did it both.
I think you have both.
Where's that?
Hey!
It was Thursday, so I was coming to class at 8:55, so I realized it wasn't Thursday.
Well, we've been recording this, so you can always go back. We're reviewing the questions for that, the module 8 to 10 questions.
It does feel like a Thursday.
Does it?
I don't know why.
And half the school is gone, and of course, all the sports teams are gone. Yep. So we'll give this next question to you, John, as you get your brain warmed up. What information does the Loopback Test provide? The Loopback Test is a test that you can run on the router, right? No, you can run on any host. Basically you ping yourself. Ping localhost. Have you ever done that on a PC?
I feel like before once, but I don't remember why.
Do you remember the address of localhost? I think you can use the word localhost. And the ping's all answered. It doesn't show. Oh, look at that! When I ping localhost, it's giving me the IPv6 address. Huh. Here's the address. Here's the IPv4 address of yourself. It's always 127.0.0.1.
There's no place like 127.0.0.1.
Yeah, that's right.
Yes.
Yeah.
Yes. Okay, I remember that.
So what are you testing when you ping the loopback? That your TCP/IP stack is working? That you have end-to-end connectivity? Does it exercise DHCP? Does it test your cable? Or does it test that you have the correct IP on the network?
I think it would be the TCP IP stack.
Yeah. It's only testing the TCP IP stack. It's not going any further. It's basically saying, oh yeah, I have network software, but I'm not really talking to any real devices. I recognize the address and I exercise the stack. Never even touch the hardware. All right, back to, I think it's Wood's. What routing table entry has a next hop address associated with a destination network? Next hop address.
Was it directly connected or local? I think it's local routes. Local routes. Maybe it's directly connected, but I think it's local.
Next hop address associated with the destination network. Next hop would be something not local. It'd be remote.
Next hop address.
So,
oh yeah.
local routes would be locally connected. Those would be the C's. Next hop would be, okay, these are the networks. To get to this network, here's the next hop.
What would be the directly connected route or directly connected routes?
Those are the networks it knows about. What's on Fast Internet 0. Here's that network there.
Okay.
And that would have the C in front of it if you didn't show IP route. All right, Jonah. How do hosts ensure that their packets are directed to the correct network destination? How do hosts ensure that they have the correct network destination? Do they always send their packets to the direct default gateway? Do they keep their own local routing table? Do they seek their own local route, search their own local routing table, and pass the information to the default gateway?
That's more accurate.
Do they send a query to the default gateway asking for the best route?
Typically, they send it to the router, and then the router sends it where it needs to go. But I don't know if that means they have to have an internal.
Well, you're correct. If they don't know where to go, that's when they send it to the default route.
They should have an internal
Yes.
routing table at this point.
Yeah, they build an internal routing table, and one way to see that, if you don't go to command prompt, you can do ARP -A, and it shows you a little table of MAC addresses and known IPs connected to various MAC addresses. So this is like a little internal ARP table, but that's part of what your PC does, and this is a cool way to debug things.
So this would only be devices that you can get on the network, though, right?
Yeah, and anything that I have connected to, my ARP table will add that address to its ARP table. So if you know there's an issue with something, you want to know what's that IP address of that machine that I'm connecting to, so I can go find where it is on the switch. Because remember, switches only track what MAC addresses are connected to which ports. Say I know I see this IP address. I'm running Wireshark. Actually, Wireshark could show you both. But I'm getting something about, I think it's so-and-so's IP address giving me trouble. What's that MAC address? So I can go hunt them down. Remember, the MAC address also gives you a clue as to what type of hardware it is, because those first three numbers are the vendor. So the ARP table is one of those things. So the host keeps their own routing table, and let's see. I don't know how to see it. Is it IP? I don't think IP config shows my routing table. Route.
Oh, I see. So the importance of this question would really come down to if the host has multiple gateways to go through.
Yeah.
Then it would have to keep track of those. Okay.
There is a route command in DOS, route print, and you can show your internal route table.
But it's obviously not going to keep track of Google and other random addresses.
I'm guessing the ones that I'm assuming that it clears it out. It doesn't get huge. But I'm assuming the things that you connect to, it will put in my routing table. I guess I'd have to see. Maybe let's do a ping of Google and see if my routing table changes. I'm assuming. Let's do it. Just do Control-C now, and then do route print. And does Google show up there? Google was over at 142.250. Does it show 142.250 in here? Gateway interface. I don't see Google added to my little routing table after doing a ping to it. But it does build a little a local routing table. Okay.
So now it builds that routing table regardless of whether or not devices are shared to the network, right? Like how
You're right,
like
right.
Windows has the share feature, you can be discoverable or not discoverable. They would have that table regardless, right?
I'm pretty sure. Yep. Okay, last one on this. And this is section 8. The last one here, and this is back to Lloyd. Oh no, this is John's question. When transporting data from real-time applications, streaming audio data, which field in the IPv6 header can be used to inform the routers and switches to maintain the same path for the packets in the same conversation? Not an easy question. Kind of a long question. IPv6, again, most people aren't as knowledgeable, nearly as knowledgeable about IPv6 as IPv4. So, again, if you are up on it, you will be a step up on those people interviewing for that networking job, or a job that requires network knowledge, even if it's not the network maintenance. The answer is, it's the flow label. And the comment in the test bank, the flow label in IPv6 header is a 20-bit field, provides special service for real-time application. This field, this 20-bit field, called the flow label, can be used to inform routers to maintain the same path for the packet flow, so the packets will not be reordered.
So, is it only you do that if the device, the end device and the start device have IPv6 properties?
Yeah. They both have to go on IPv6, and essentially you want to maintain good quality service, keep the same path. I think it will speed up the transmission interaction. This is the last in the test bank of Module 8. Let's go on to the next one now. We're going Module 9 now, talking about dynamic what do they call it?
I have an interesting question real quick.
Uh-huh.
So like when you got a home network, you have like just a standard wireless router that connects to your modem or however it's set up.
Okay.
And you change your IP address on your like one of your personal computers.
Yep.
Does it just automatically update an address pool, so to speak?
Well, it updates the MAC table in the wireless router. There'll be a little delay, but it'll realize, oh, the same IP address now is, or a different IP address is on the same MAC. It'll generate a log message. Hey, a MAC address, my MAC ARP table changed. That could signify an attack on your network, or somebody just decided to change their IP address. It logs that and then lets you through. On firewalls that are set up securely, if you change your IP, it'll say, hey, we just got an ARP. We detected an ARP mismatch. Different IP, same MAC. They could disable that or just say, okay, we'll log that as in our error log.
The risk would be that somebody could clone the MAC with a different IP.
Yep. Okay, ARP message. This is to Lloyd. What statement describes the function of address resolution protocol? Basically, which is true. It's used to discover the IP address of any host. You discover the IP address of any host on a local network.
Second one, the ARP is used to discover the IP address on any host on the local network.
What the bottom one?
Because you use ARP, you already have the MAC address. You're looking for someone's IP address.
That's reverse ARP.
That's reverse ARP?
Yeah.
Whoops. In which case, bottom one.
Yeah, it's the bottom one. Yeah, reverse ARP is finding what MAC or what IP is associated with a MAC. Think address resolution is I need to get to that
Resolve what
device.
this IP needs. That's what it is. I need to resolve what this IP needs.
Yeah. And if you run Wireshark, which is a great tool just to learn what's happening, you see that message is flying by all the time. Who has IP address? And you get the the reason you see it on Wireshark is because it's broadcast. Everybody sees ARP messages, which is one of the questions. It might be the next one. Let's see, Jonah. Which two circumstances will a switch flood a frame out of every port except the port that the frame was received on?
Broadcast? But it receives if a frame it receives a broadcast frame from the one received.
There's two options. Choose two. So what was which one did you choose so far?
The first one, broadcast.
Okay. And we're talking about a switch. So a switch is working on MAC address.
Oh, the destination address is unknown.
Right. The first two. We're talking about switches, which is at level 2. They don't keep track of IPs. And when I don't know the destination IP yet, because it's not, I don't have my ARP table built, or I don't have my MAC table built, then I send it to everyone, and then the one that answers me is the one that I say, oh, you're the port that answered that MAC address. Or when it's a broadcast. Very good. All right, John. Which statement describes treatment of ARP requests on the local link? Treatment of ARP requests on the local link. And remember what an ARP request is. It's that who has this IP address? That's a little clue there. That's what you see in Wireshark. Who has IP 10.172.3.4? That message. When I do an ARP request, I'm asking for who has an address. I don't know who has that address, so
I'm going to go with H as the only one that I can decide is definitely true.
Forwarded by all routers? That's what you're saying?
Yeah.
Not quite.
For sure, no? Okay.
We only stick on the local network. The router is one of the devices on the local network.
Because it uses the term they received and processed, and I wasn't sure
Yeah,
process was a good term to use for this.
Oh, right.
Maybe that's meaning like they respond.
Right. Yeah. Right. Responding is part of processing. The router only for switches, for ARP requests, the router is just another device on the network.
Oh, see, I was thinking of
So
that.
you don't want to find out about all the other
routers,
devices.
So that way the routers would ask all. Okay, I see.
Yeah.
So it's only on the most local
Yeah.
network.
This would be a really bad thing if routers forwarded ARP requests. The internet would be
Oh,
flooded.
that's true. That's true. I was thinking of like a small internal
Right.
multi-network.
Right.
Okay. Then. So when it's processed, do PCs that do not match the IP address, do they actually respond?
They drop it. Yeah.
Oh,
They
drop
get it and they say, no, that's
so
not me.
They process it and then
Yeah.
they drop it if it's not them.
Yeah.
Oh, that
So
makes sense.
the key is process means they got to them and they
Gotcha.
decided what to do with it. All right, back to destination for an ARP request. Basically, it's a broadcast address. And the question is essentially, what is the broadcast address? IPv
address is the second one. 255.255.255.255. No. Well, it's the broadcast address.
I think IPv4 is not quite. This is the broadcast subnet mask.
Yeah. But
That's an invalid address.
You know, the address would just be the broadcast address, which would be the very last address on the network. So it can't be the physical address of the destination host.
The
Right.
destination
Know
address is used in the
Remember, this is the broadcast address. They're giving you both a mix of either IPv4 or IPv6. This is not correct IPv4 broadcast address. And let's see what it is for IPv4. ARP request address IPv4. I forget the address myself. It is.
If they're asking for IPv6 now, below, why don't they add 3 seconds?
The broadcast address is a MAC address.
Ah. So it'd be the last one.
So the last physical address?
No, the MAC address, all
Oh.
ones. There's an odd form of MAC address. I usually don't put them in this form, but that's the MAC address
Okay. Oh, those are representing MAC address. Oh.
Yeah.
I'm looking at those like that's not.
Oh, yeah. So they're not. So they're not IPv4. They look like IPv6, but they're too short for IPv6.
Right.
They don't have the colons in there like they're supposed to.
Okay, so
it's
okay. Right. Okay.
Okay, Jonah. When you say ARP -D on a PC after routes connected, what is the result of it after this command is issued? I'm going to see if it works on mine. ARP. I did an ARP already. I did an ARP -A, ARP -D star. Actually, I'm doing ARP /? before I do that. -D deletes the host specified by that IP address. So -D star, can you guess what it's doing? If -D and then a host name deletes that entry, if I do a -D star, what's the result of that? Yeah. You're going to clear your ARP cache. So let's do that on mine. I'm going to come over here. For me, doing it, actually seeing it happen, let's do ARP -A. There's my ARP. Let's do ARP -D star. And, oh, the ARP entry deletion failed. Oh, it won't let me do that unless I'm running as administrator, because that's a dangerous command. ARP -A. I can read the ARP table. I can't delete it unless I'm running as administrator, so I'm going to do that just for fun. Right-click on my command prompt, run as administrator. I get a new window, get the permission request, and now let's do ARP -D star. And now let's come back to this guy and do ARP. This guy, let's do ARP -A, and I don't have many entries anymore. But watch what happens. I'll ping www.google.com. And now let's do ARP -A. Does something change? I've got a few addresses added to my tables really quickly. One of them is my... Well, I already have the default gateway in there. But it looks like my PC has been talking already over the network, and the ARP table is starting to fill up. Another way to debug your network, clear your ARP table, do nothing, and you'll know who your PC is talking to in the background. By seeing, oh, I've got some ARP entries. I haven't been doing any web addresses, web surfing. Of course, if my browser's open, it's talking to the website, so that's part of it. But I'm getting some local addresses. One of them is my Active Directory server. I know that just based on that address. 16. I don't know why I'm talking to 16. Maybe I have a Windows file share to him or something. But he's in my ARP table without me doing anything. After it immediately shows up after clearing my ARP cache. So that's a great way, another way to possibly troubleshoot. All right. Jonah question. Or is that a Jonah question?
Hey, could you try the IP table or your ARP table thing?
What's that?
I want to see if can you try it one more time? I want to see if when this PC would connect to the house. Oh, it hasn't.
This is 12. You're 12.
I'm 12.
But 11 showed up. I don't know what's going on. 11, 13, and 14. About everyone. 14 is nothing happening on that. Maybe I have a share or something. But it's interesting how. You remember they may be doing something like doing ARP requests, and maybe that causes even me responding or seeing ARP broadcasts may cause my PC to do an entry. That's all kind of interesting to me. Well, we are out of time with that. This review of the various questions will I'll upload it. Zip through your 8 through 10s and give a try on that module 8 through 10. You have until, let me check when you have it. I'll update the schedule on Schoology too for you. I have it enabled in Netacad, and I will go update that in the quizzes section. Do I have that in the quizzes section? Subnet practice, physical lab. Where is that? Did I put that in the homework sections? Assignments? Maybe it's sitting there in the assignments section.
Should be under assessment.
Yeah, I'll put it under assessments. It'll be a placeholder. I'll do that right now before I forget. before Mr. Elliott gets in here. Quizzes.
Thank you, Professor.
You're welcome. Have a great day.
I haven't had a chance to try the TFTP for the second server yet. Again, I think I'm just gonna completely get rid of router RIP and reconfigure that and see if that will just do it.
Yep.
Good. Interesting thing too is I just did the ARP-A on this computer,
Mm-hmm.
and it shows the. Actually, did it? Oh, it won't show anything from the other routers addresses at all, will it?
No.
That's interesting. Sometimes I kind of forget that it actually does have a barrier there.
Yeah.
Because the way we're learning and configuring classes seems like, oh, this is all it's
Right.
one network.
Yeah.
But it's actually two. Oh, it's true. Yeah.
Morning, Saya.